So, can I talk to you for 2 minutes?
Yes, sir.
Allow you. Okay, so what I wanted to say is, if I have to teach you, okay, you have to give me 5 minutes. If I have to teach you, give me a silent and that's what I. What I'm observing like the last lecture. Okay, so I come here to give you so many things, right? But if there is too much noise, then my efficiency level goes down. Energy is conserved. So I can use that energy either to teach you or to discipline you. So it's in your interest that you give me that environment. Because I come with 100% energy, right?
Yes,
I can only give you 100%. So you decide the workload for me. So try to be like, focused so that don't chat amongst yourself. So that will do the difference. होता क्या है ना अभी साउंड में मैं आज डेसिबल पढ़ाने वाला हूँ प्राइस लेवल so that whisper is around 30 decibel okay and pin drop silence is 0 decibels it is 0 decibel right but 0 to 30 is not 30 times you know how much it is it's at a logarithmic scale it's not linear 0 to 30 is not 30 times it could be 300 times or even more. So when the combined whisper of everybody, okay, that becomes quite annoying and distracting, difficult to focus on. So not good for anybody, right? Not for me, not for it. So I have said what I had to say, rest is up to you. And I've also decided to send some of you outside. Okay, so please do not mind it. Just mind your actions. So I'll be sending some of you out. If I find you not taking cognizance of what we have just discussed. So few will go out. Okay? तो उसमें बुरा मत मानना. Just for the sake of discipline, I will do this. Okay? All right. So in the last class, we had classified correct. And resonance is special case of force vibration. That is resonance. Okay. So can you give me examples of resonance from real life? There are some in your textbook. There are 5 pendulums. Yes. So how? How? Pendulum, how? So there is a question given in your book. Let's discuss that. There are 4 pendulums, right? Let's say 4 pendulums. Let's call this as A, B, C, D, 5 pendulums. Okay. How are these pendulums hanged? They are hanged over a rubber rod. Rubber rod. So the rod is not rigid. Point number 1. Is the rod rigid? It is a rubber rod. So now what is being done is this is set in oscillation. So what is the plane of oscillation? This, the plane perpendicular to the board. So this pendulum is oscillating like this towards you and into the board. Okay, it is in this plane, vertical perpendicular plane, right? So what is seen is now when this starts oscillating, right? So it will start twisting the shaft. So this vibration will reach this pendulum, this. Okay. So the twisting of this rod, let's say this is twisting like this. Okay. If there is an oscillator here, it is twisting the rod like this. So therefore that motion is disturbing all the other pendulums. So this will also start oscillating, this also, this, everything will start oscillating. But what is observed is that they all oscillate with smaller amplitude, but A and C oscillate with the same amplitude. Okay. This is small. So now question. Why A and C oscillate with the same amplitude? Right? And what are the kinds of vibrations caused in all the 4 other oscillators? Oscillator is pendulum only. So it is a force vibration. What is the first answer? It is force vibration. Because who is causing the vibration in this? This guy, right? Now, A and C are oscillating with same amplitude, right? Why? Because what should be their natural frequency? Their lengths are same, right? And what is the frequency of pendulum? L by G or G by L?
L by G. G by.
Because time period is 2 pi.
2 pi root of L by G.
L by G. Okay. So frequency is a function of L. Everything else is constant at a given location because these are all pendulums are at the same location, right? No. So what is the frequency? It is a function of L. So length in this case is same. So their natural frequency is same, right? So when I set this in vibration, it will start vibrating with its natural frequency, right? And it is causing force vibration on others. So this frequency, its natural frequency matches the force vibration on this string. Okay. Therefore, these two are oscillating with maximum amplitude. Okay. All others are vibrating with smaller amplitude. Because their natural frequencies are different. Lengths are different. No? So the force vibration is not matching the natural frequency of other pendulums. That's why they are just force vibration, but they are not resonance. So between A and C, what is caused is resonance. Resonance. Okay. And all other are just a case of force vibration. Understood? So this description is given in your book. Now you should be able to understand it better. So there are some 7-8 cases. In the last level, did we complete all those cases? We just defined it, right? All the four types. Okay. So what I suggest you is, you just go through all these experiments. Experiment 1 with the tuning fork. Okay, can you quickly read it? Sorry? Because there may be question based on this. So there are 3 experiments and 7 examples. 6 examples. So this I already explained. So, experiment 1. Can I discuss experiment 1? Yes. Okay, chalo main discuss kar deta hu fatafat. We discussed second one, right? And then the third 1 and 3 I will explain. Let's say you have a sound box like this. This is a sound box with this side open. Okay.
Yes, sir.
This side is open. And you create, everybody is familiar with tuning fork, right?
Yes, sir.
So when you hit a tuning fork on a rubber pad, it starts vibrating and you will hear its sound. Whenever it is vibrating, you will hear a unique sound. So every time you hit that tuning fork, it will show, you will be able to hear a sound. but that sound coming only through the tuning fork will be very feeble, very small. Okay. Now what you are doing is you are keeping that vibrating tuning fork on the sound box. No. A vibrating tuning fork is pressed. Let's say this is the tuning fork, and I'm keeping on the surface. So when you will be conducting experiment in school, I don't know whether that experiment is there. The surface of the table will start vibrating, and suddenly the sound will be more. Why? Because this surface has a bigger area. Okay. So then the intensity of sound increases because energy transferred per unit area per unit time. So more area vibrating will produce larger sound. Got it? So now what is happening is when this tuning fork is vibrating in this direction, both its prongs are going like this. This is very slow motion. It is very fast. Okay. So this vibration will be transmitted in the sound box, and there is air inside. This is a hollow sound box covered from all sides, just on this side open. So this air is vibrating, set into vibration. So anything which is vibrating will cause sounds. Okay. So this sound wave will begin to transmit, and there is a similar sound box kept here. Right? There is a similar sound box. Now this air which is vibrating, sound is traveling through compression and rarefaction, and now it disturbs the air in this sound box. Okay. Here, an identical tuning fork is kept. Okay, an identical tuning fork is kept. So you basically vibrated this tuning fork, kept here, those vibrations reached here, and they caused this tuning fork vibrating. Now this is an identical tuning fork. So they are now started to vibrate at the same natural frequency. Therefore, you can clearly see the sound multiplying. So first it caused a forced vibration on this tuning fork. But this tuning fork's natural frequency matches this tuning fork. Therefore, now you will hear two tuning fork vibrating in resonance with each other, and now the sound will be more. Would be double or even more at resonance. See, it's like this. When you blow air in it, it has air column in this. Now I am blowing air. When the air column ka frequency matches my blow frequency, then you whistle aaye. That whistle is resonance. Same thing, somebody might whistle it with more sound. Okay, so this is resonance. So हर एक का frequency अलग है. Sound is different because sound is different because frequency. Okay, silent now. Silence everybody. Sound is different because the frequency of every object or every air column. So that thing is an air column. Okay, now understand what is the air column. So if this size was double, the length of the air column will be doubled. Okay. Now, is experiment 1 understood?
Yes.
How it is resonance. Now experiment 2 I have already explained. Look at experiment 3. Okay. Now experiment 3 is what is experiment 3? Now, this is water reservoir, and it can be move up or down, right? So depending upon whether we are taking it up or down, this level can be altered because liquid finds its own level, right? Pay attention here. Now what is being done is, what is the length of the air column right now? This is the air column. जल्दी से समझ नहीं आता क्या? Pay attention now. So what is air column? This is where the air is. Okay. So this air column can be altered, right? Now what is being done is, you are taking a tuning fork. This tuning fork is vibrating, and this vibration of the tuning fork are forcing vibration in this air column. Okay, what is being done? Hit a tuning fork and keep it above this. So what is this? This is air column, right? So this air will be set in vibration. Now when the vibration of air matches the vibration of the tuning fork, that time you will hear a loud sound. And that loud sound is due to resonance. Okay. So in this experiment, you will discover when you change the air column, okay, you will see resonance taking place at various length of the air column. Understood? What did I just say? Yes? What did I just say? Stand up. So what did I just say? When you hit a tuning fork and keep it above the air column, right? For a particular length, right? So what you will do, first the level is matching to the brim. Okay. Yes. First the level of the water is matching to the brim. Now you start increasing the air column by changing this, making it up and down. At one length of air column, you will hear a loud sound. That is resonance. Okay, that is first resonance. Again, go on increasing that air column. You will find another loud sound. That is second resonance. Meaning, for different length of air column, okay, you are getting resonance. When will resonance happen? When the frequency of vibration of tuning fork matches the frequency of vibration of air inside the column. Yes. Why rubber tube? Because this water is connected, no? Just to give a water connectivity. Okay, sit down. So this is what is the demonstration of resonance. These experiments are just to give you a demonstration of resonance. Is it understood? Okay. So more details not expected. Just to understand why the resonance is taking place. Resonance is taking place because the frequency of vibration of the tuning fork is matching the frequency of vibration of air molecules. Okay. So whenever the two frequency match, that's when vibration will take place with maximum amplitude. So higher amplitude vibration will be louder to hear. Understood? That is resonance. Okay, that's experiment 3. So all 3 experiments we have covered now. Okay. So is the difference between force vibration and resonant vibration clear to all of you? So, is it clear? There is a difference. There is a table given in the book. Just read through all the points. Read these points, everybody. And if you have any question, just ask me right now. Because we need air column. So empty, how will you change the air column? You can do that, yes. But this is flexible, no? This is convenient. In the same apparatus, you are able to change the air column. Rather than having 3 different apparatus. In one apparatus, you are able to change the air column. Yeah. Budget issue or smart thinking? Smart. Okay, so forced and resonant vibrations I had already covered in the last class. So I think we will move ahead to some examples of resonance. What are some examples of resonance? There are some 6 examples of resonance. Yes.
Yes, sir. So the soldiers are allowed not to go in a march first.
Yeah, they are asked to break their pattern, right? So why is that?
Sir, because during the march past, so the foot when we stand the foot on the bridge, so it also creates a vibration.
So bridge also has its own natural
Yes, sir.
frequency.
So when it matches the bridge for us.
The bridge may start vibrating with a loud amplitude, which may cause the bridge to swing with large amplitude and eventually break it.
Yes.
Yeah. So little bit of vibration is okay, but if it starts really swinging, now I haven't seen it. We have only been reading about it. So if there is any accident,
Sir, during COVID, what could happen?
it happened. Okay, so I've not checked. There is a YouTube video.
But no, sir.
YouTube video तो नहीं होगा, but ठीक है, there might be some. Now there is another example. Is there an example on earthquake? So resonant vibration in pendulums that we already discussed. Okay, if the pendulums are of same length, they will both start oscillating with a very large amplitude. Okay. Resonance in machine part, the second one. What is it? Can somebody explain? Resonance in machine parts.
You had explained this in the class.
I had explained it.
Piston, up and
That is not resonant.
say much.
That is converting the vibration into linear motion. Oscillatory motion into linear motion. That was it. Can anybody explain me what is resonance in machine parts? So anybody has experience of traveling in BST bus?
Yes, sir.
Okay. So when the bus is at low gear, okay, when he picks up, right? When he rolls,
Yes.
it vibrates too much,
Yes, sir.
right? Okay. So what is happening?
Since
So
the piston is not able to match it,
So the piston vibration is maybe matching with some of the parts of machine. So they all come together and resonate at a very high, है ना? सब लोग resonate हो जाते हैं. तो उसके बाद क्या होता है? He changes the gear. Then it comes down. Okay. Now the frequency has been mismatched. Okay. Not BST, the bus. You can observe it in the bus because everywhere, even in aeroplane, when you start hearing large sound, okay. So when you change the speed, either increase or decrease, both case, you just have to break the frequency tally. Okay. So you can break that by increasing or decreasing the speed. Okay. So when there is a loose nut, okay, it makes a lot of noise, even in a fan or something. So have you observed sometimes a fan makes noise at one speed, but when you change the speed, the noise stops.
Yes.
That is what it is. So when two frequency match, a large annoying sound will be produced. But you change the speed, then it is broken. Okay. Okay. So these are practical. Then you have resonance in a stretched string and sound box of musical instrument. Now see. So you have a stretched rubber band, and when you plug it, does it create sound? Now stretch it near the sound box of the guitar. So when you plug the string of a guitar near the sound box, then you hear a louder voice. Because now resonance is created. The air vibrating in the sound box has a bigger area, like in earlier case. Okay. So that is why we use sound box, so that with the help of resonance, we are able to multiply or amplify sound. Got it?
Yes, sir.
Okay. So this is the application of resonance in case of musical instrument. Resonance in air column and tuning fork we have already discussed, right? Resonance in bridge we discussed. Now resonance in radio and TV receiver. I've already explained that.
Yes, sir.
So is everybody online student? Are all of you clear on what is resonance?
Yes, sir.
Applications?
Yes, sir.
Yes, all of you.
Yes, sir.
Okay, ठीक. Chalo. So with this, I'll move on to the last unit of this chapter. Yeah. This is our fourth lecture or third lecture on sound. Third lecture. Right? So we are yet to solve numericals in this chapter.
Yes.
Sir, और भी है ना?
Yes, sir. We have to solve.
Seven CD.
C. Abhi, now I am discussing C, but we have one more lecture for this, right? I mean, we can take more than one. But this is my third lecture. Okay. So let's move on to unit C. Unit C. So what is unit C? It's all about, so many, I mean, not the entire chapter is for exam. Okay. Lot of portion is related for exam. Okay. So don't worry, it's only the theoretical part which is there, right? So from unit C, you only have characteristics of sound. Yes. So what characterizes sound? How do we differentiate between different sounds? Right? Like if it is metal, we can go by its appearance, right? Gold looks like yellowish, silver is whitish or grayish, whatever. But there are various traits of a metal to figure out what kind of metal it is. Likewise, how do we differentiate between different sounds? So we differentiate sounds by its loudness. So the first characteristics is loudness.
Intensity.
We'll come to it. Then you have pitch. Then you have quality. Okay. So loudness of sound depends on amplitude. Right?
Yes, sir.
So loudness of sound depends on amplitude. See, how do we measure? Like we quantify. So we have for wave, what are the terms which describe wave? Amplitude, time period, frequency, wavelength. Okay. So, and sound is a wave, right? So all sound wave should have we should be able to specify in terms of amplitude, frequency, time period. Okay, because those are the basic characteristics of wave. So how do we, relate soundness with? We relate soundness with amplitude. So let's say I have two waves, two sound waves. Right. So we have, let's say this is one cycle of a wave and another one is something like this. So tell me the similarity and difference between these two waves. So these waves have, like, this is double the amplitude almost, right? This frequency is more different. So same frequency, right? But amplitude doubled. It's doubled. Will the loudness be doubled?
Yes.
It varies at square of amplitude. Okay, 4 times we are. There's no linear variation in sound. Okay, so so then we have to understand. So what is loudness then? It is only perception based. What is loud for me may not be loud for you. Let's say I'm a fan of, like, say, classical music. So it is played at a low one. Kishore Kumar or मैं भूल गया। It is loud for me. The noise in the classroom may not be loud for you.
Yes, sir.
You understand? So loudness is subjective.
Yes, sir.
Such things are called subjective because it is a matter of sensation.
Yes,
Sensation, right? So like if somebody is very old बंदे के बाजू में बैठ के तू बहुत चिल्ला के उसको बता रहा है तो भी उसको because the ear drums have lost the sensitivity. They are not like a newborn or a young boy, like a charming boy like you. It's good. Okay. It's good sometimes to be, delicious. No harm. Loudness depends on loudness is subjective. Subjective means you cannot give it a objective or concrete fixed value. It is different for different people. It is as per sensitivity or perception. Okay. So you may like rock music, right? So unless it is very loud, your mother will just start scratching his ear. But you are like really happy. Okay. What should I do? Not a message. Intensity of sound. Intensity of sound is objective parameter. Now, objective means something that can be specifically measured. Okay. So how do we define intensity of sound is objective? That is, it can be distinctly. Okay. So you understood what is subjective and what is objective? Subjective is perception based. Okay? Whereas objective can be distinctly measured. Okay? So it is experimental, right? Experimentally different. And how do you define intensity? What is intensity defined as? Energy flowing per unit area per unit time. What is intensity? Intensity is okay. So what energy upon time is? Hour. Okay, so intensity for any sound can be experimentally measured. Objective है quality. तो objective का मतलब क्या होता है? Can be measured. मतलब experiment में it can be verified. So वो अलग-अलग sound की intensity अगर अलग-अलग है, ठीक है? We can give it a value. The sound is different than thoughts of it. Second, कोई confusion? Subjective चीजों में confusion होता है. कोई एक साउंड किसी को लाउड लग रहा है, किसी को कम लाउड लग रहा है, बट इंटेंसिटी एक्जेक्टली बता देगा कौन सा साउंड. ओके, सो वी कैन स्पेसिफाई इट विदाउट एनी कंफ्यूजन. बैठ जाओ, सिट डाउन. सो लाउडनेस इज क्लियर. नाउ let us talk about the next characteristic of sound, which is pitch. Okay, so it is your objective quantity. Let us now discuss about pitch of sound. What depends on pitch of sound depends on frequency. So in this case, pitch is subjective, frequency is objective. So pitch of sound is subjective, whereas frequency is objective. Every different sound has a unique frequency. Okay. Now, what kind of sound is male sound?
High pitch.
Low pitch.
So male is low pitch. High pitch. So female voice is high pitch. So ladies are like feeling proud, right? Females are feeling proud right now. They are slowed over well. This is a very different matter. This is a very different matter, right? Here high is not good. Yes. Okay. Because high pitch is Now, what is shrillness? Shrillness means how do I demonstrate it? So let's so in music, right? If you're singing, right? So how can you differentiate between a high pitch and a low pitch? So let's say I am saying I don't shrill. Say one second. It's like okay, what is the shrill voice? Once again, you are eating your favorite dish And easier than oh, what will be your main treatment after seeing the problem? That is a shell. How will a male react? Re baap re. That is a flat. Okay, this is flat voice. Male as a flat. It is also called their high bass. Voices. So treble. Can anybody mention difference between so have you seen tabla? Which has high bass and which silence. तबले में दो होते हैं ना So the bass is okay, high frequency. So इसमें dum So here we have one cycle which let us say how many cycles we got in the same time? So what is the difference in frequency? What is the frequency? 3.5 times more than this. Okay, because it has 3.5 cycles in the what is the number of so the class is not over. Okay, look at it. So what is the difference between two graphs? Second one is 3.5 frequency of the second graph.
Sir, it's 3.5 or 4.
Okay, what is the difference in the second graph? Second graph shows How many cycles for the same duration?
3.5.
3.5. नहीं लेकिन संज्ञा नहीं है। मतलब क्या है? आप लोग बताओ। Frequency levels. Secondary frequency ज्यादा है क्योंकि इस चीज completing more number of cycles में the same duration. So this amplitude से yes amplitude से also can you see the vertical displacement? It is same, right? So in this case amplitude is same. Okay. The amplitude is same. The frequency is small. You see it? Amplitude same, frequency is okay. This cannot go. Now the last characteristic is what is the last characteristic? Quality. Quality of sound. Now suppose चलो तुम बाहर चले जाओ. You want to go out?
Sir, he is not up. He is blind.
Okay, you look ahead. तू सामने देख रहा. हमेशा what is quality of sound? What is quality of sound? Quality of sound. The third characteristic is quality of sound.
Which is in two kinds of sound with same pitch and
Yes. So suppose I am giving you two sounds having same amplitude and same frequency. Still they are looking, I mean, you are seeing them as, hearing them as different sound. Okay. So on what basis will you be able to do Azra?
सर ये दोनों कब से हंसते जा रहे तबला बजा रहे सर टेबल पे तो सर बाहर कर दो सर गजरा गा रहे सर गजरे आप
सर ये बोले गेंदा फूल से तबला
कितना?
गेंदा फूल
मैं बजवाऊंगा तेरे से. 2 मिनट बाद बजवा. So what is quality? Quality of sound is needed to identify the source of sound. Everybody, quality of sound is needed to identify or differentiate between two sounds which has same amplitude and same frequency. Okay, but still they are sounding different. So what could be the situation here? Those sounds are coming from two different instruments. Okay, like ये दोनों बच्चे हैं. तुम okay? अरे यार बच्चियां दिख रही हैं. ठीक है. दोनों की यूनिक साउंड है ना. दोनों अगर सेम लेवल पे बात कर, जैसे हम बातचीत कर रहे हैं नॉर्मल, इसकी भी एम्पलीट्यूड सेम है, इसकी भी एम्पलीट्यूड सेम. ठीक है, फ्रीक्वेंसी भी सिमिलर है, लेट अस से, but still I hear them differently because the source is different, so their quality is different. Understood? Yes sir. So you differentiate. So then how do you differentiate such sounds जिसका एम्पलीट्यूड भी सेम है और फ्रीक्वेंसी भी सेम है from their waveforms? Okay, so sounds with same amplitude and frequencies are identified are identified their qualities. इसका कोई मीनिंग निकल रहा है क्या? आर आइडेंटिफाइड by their okay, by their waveforms, right? So let's say you have two sounds. One is like this. Online students, are you able to see the board this side?
Yes, sir, we are able.
कैमरा ऑन करके क्लास छोड़ के भाग गया सर। आदित्य को देखो, आदित्य को कोई है ही नहीं।
So now we have, let's say we have a different kind of wave. Okay, is the waveform same or different? Different, of course, different. Let's say this is from a guitar. This is from a sitar. Right? Two different musical instruments. Okay, they are producing sound at छोड़ देता हूँ कि बाहर आ लगे क्या प्रायोरिटी ठीक है तो क्वालिटी सबको समझ आ रहा है क्वालिटी है हाँ बेटा खड़े क्वालिटी एक्सप्लेन कर तू आगे देखने जब मैं सर में हमेशा मेरे पीछे करके बचना बहुत चौधरी होता है हाँ व्हाट इज क्वालिटी पढ़ ले लिखा है यहाँ पे पढ़ के फिर बताओ
देख के पढ़ अभी देख
बाकी सब लोग शांत
ओके सर
पढ़ो तो पढ़ो तुमने पहले के दो सुने व्हाट इज लाउडनेस एंड व्हाट इज पिच बताओ
Sir, quality of sound is the difference between
एक मिनट सुनो लैंग्वेज इशू है ना तो हिंदी में बात करो बताओ ठीक है दो साउंड जिसकी एम्पलीट्यूड भी सेम है और फ्रीक्वेंसी भी सेम है फिर भी हमको अलग अलग सुनाई दे क्यों ऐसा कब हो सकता है जब दोनों both sounds are produced by different sources like different एक फ्लूट है और दूसरा तबला है सेम लेवल पे बज रहे हैं बट दोनों अलग साउंड बिकॉज इनकी वेवफॉर्म अलग है ठीक है so that kind of differentiation is identified by quality और उसको timbre भी बोलते हैं quality या फिर it is called as timbre ठीक है इसमें ऑब्जेक्टिव सब्जेक्टिव का फंडा नहीं है it is just the musical instrument or the source of this that's it and they can be differentiated only on the basis of their waveform ठीक है बैठ जाओ थोड़ा यार तो यार तुमको टेस्ट पेपर लेके बैठे हो कहां से लिख पाओगे तुम and when I'm explaining concept physics is very conceptual you miss the concept in school you miss the concept here when are you going to gain the concept सीधे on the exam जानते नहीं होगा ठीक है तो this is online student do you have any issues with the concept here difference between loudness pitch and quality all of you understood
Yes, sir.
okay Shaurya is not with us
No, sir, I'm here. I have network issues actually.
Okay, so you didn't say anything like, do you have any issues?
No, sir, I have no issues.
Concepts?
I can't speak a lot of things because my data is low actually.
Okay, okay, understood. Now I want all of you to comment this table. So in this chapter only, this is there. Okay? Come to this table, right? So how the sound level is measured? It is measured in decibels. Sound level is measured in decibel. How it is written? Right? And you see the different sound levels. Like for the pin drop, like I said, it is 0 decibel. Whenever a pin, so we say pin drop silence, right? Meaning you can hear the sound of the pin. Actually, it will not produce any sound. So that sound is called 0 decibel. Okay. But now you have leaves rustling. जो पेड़ के पत्ते हिलते हैं ना,
That 10 decibel.
that is 10 decibel. So that 10 decibel is not 10 times. It's much more than that because this rise is logarithmic. It's not straight. So 10 is not 10 times, much more than that. Then if you look at recording studio, okay, come to soft whisper because even in recording studio,
30.
recording studio is 20. Soft whisper is 30. But then you are not doing soft whisper. You are doing what? Conversation. That is 50. Okay, so 50 में कितना और multiply हुआ? Not 50 times, much more than that. Okay. Then we are okay with sound till 120 decibel, which is the sound of siren, police siren or ambulance siren. And beyond that, you have pop concert. So then it is noise. Okay. Beyond 120, it is noise pollution. Okay. So what kind of a sound is a noise which is unpleasant to hear? What kind of a sound is music which is pleasant to hear? Okay. So this limit you should understand. Anything more than 120 decibel qualifies as
Noise pollution.
and then you have jet takeoff.
Then 140.
140, and there are sounds which are so loud which can send shock waves, like jet takeoff and all, right? So we don't have any military airbase nearby. Sound required to make us deaf. Anything which is in excess of 120 decibel, you listen to it for a long duration, you will become deaf. If you listen to it for less duration, you will be temporarily deaf. You will be deaf for some time, but your hearing sensation will be restored. But if you are like on the Walkman, you get the alert, high sound levels, reduced volume because of that. So you are not advised to hear at a very high volume level for practical. 120 तक टेम्परेरी मतलब थोड़ा थोड़ा उसमें तुम सुन सकते हो लेकिन लगातार सुनोगे तो फिर डर तुम्हें डर बनना है All right, in the next class we'll do the practice.
That's what this.
Mania.
दुनिया का बात
तू रहने दे भाई, तू रहने दे।
हाय सर एकदम फ्लो में आ गया
रहने दे भाई, दोस्त नहीं। 185
अंदर है क्या?
नहीं, मैं पढ़ रहा हूँ।